Hello and welcome to Eyes on Research, the podcast that digests the latest scientific innovations in eye research using simple and understandable terms. I am your host, Thales Guimaraes, medical doctor and clinician scientist at Moorfields Eye Hospital. Hello, my friends, and welcome to another episode of your favorite science communication podcast focusing in the eyes and the vision. I hope everything has been well with you and that the week has been fine so far. This is the third, and knock wood, it will remain fine. This is the third episode of our new series, Eyes on Research Guide 2. And today we'll be talking about something that has been requested many times. We'll be talking about eye color. So this is your Eyes on Research Guide to Eye Color. Now, there's a lot of things that need to be discussed, but let's start from the very basic, the very beginning. When we talk about eye color, what are we talking about exactly? We really are talking about iris color. The iris is this structure that's present in the anterior or the front section of the eye that is responsible for controlling the size of the pupil amongst many other things. And the pupil is this eye aperture. So it adjusts the amount of light that reaches the light sensitive cells that we have in the retina, which is in the back of the eye, and these cells allow us to see. So the iris is a tissue with quite a bit of pigment. Now, I don't want to focus much on the genetics of eye color because we have a full episode on that already. If I recall correctly, is episode 4. So go check it out as I explain this in detail there. It's a full 25-30 minute episode just on the genetics. I just wanted to outline here that there are 16 genes, 16, that we know of that contribute to eye color. But how does that work? Well, pigment formation is a multi-step pathway with various minor and major genes contributing to this path. Think of it as a staircase, right? And you want to go up the staircase, and at the very end of the staircase, you reach to the pigment formation, right? You ended this procedure. There are many small and many bigger steps on this way that you need to climb. So this means that iris color is a complex polygenic inheritance. And that's not exactly what we learn in schools, right? In schools, we learn the model of blue eyes are a recessive trait. So two blue-eyed parents can only have a blue-eyed kid. And, this works in most cases in the context, okay? Only in the context of the main blue-eye gene named OCA2. That's the name of the gene. But it's not exactly accurate in all cases. In fact, this monogenic model, meaning that there's a single gene that is recessive to the brown gene and that causes blue eyes, was put forward by a researcher named Davenport in 1904. That's more than a century ago. In fact, it's a century and 20 years, right? 120 years ago. So because many genes are responsible for eye color, it is possible for two parents, for example, with oculocutaneous albinism, which is a genetic disease that causes diffuse lack of pigmentations and eyes that are very blue, to have children with darker colored eyes. How is that possible? Well, there are several genes controlling eye color. So it's possible that these two parents have albinism, but because of mutations on separate genes. That would mean that the child will inherit one mutation in a gene X and a second mutation in a gene Z, for instance, right? So they would have a single copy of a mutation in two different genes, and in this case, they would not have blue eyes or albinism for that matter. I hope this makes sense as an introduction that I just wanted to talk. But if not, again, go give a listen to the episode on genetics of eye color, because this is detail a little bit more in there. So what are the pigments that give the iris its color? The primary pigment in the iris is named melanin. This is the same substance that produces hair and skin pigmentation. It is a dark brown pigment, meaning that the more melanin you produce, the darker your eyes, your hair, and your skin will be. The amount of melanin in your body depends on a few different factors, which include some genetic factors, as we have discussed previously, and for instance, how much sun exposure your ancestral population had. A second pigment that also contributes to the color of the eyes is lipochrome, right? Also known as lipofuscin, which has a yellowish color. These are the two main pigments present in the iris. So this means that there's no blue or green pigment in the eye. But wait, how do people have blue, green, or hazel eyes? This is the $1 million question, isn't it? Well, the phenomenon that explains this is called Rayleigh scattering. Now, this is the same phenomenon that explains why the sky is blue. In the eyes, specifically, when there is a low concentration of melanin, less light will be absorbed and more is going to be scattered, more is going to be reflected. Since light rays with shorter wavelengths, so the blue and then the green spectrum in the medium wavelength, they scatter more easily than lights with longer wavelengths. So for example, the red spectrum. This means that eyes with less absorbing melanin will appear either green or hazel, and eyes with even lower concentration will appear blue. So blue eyes are the kind of color that we call structural, and that's just because there's less melanin and there's more scattering of light, and because the wavelengths in the blue spectrum are shorter, that's how you see the eyes. Now remember that we have lipochrome influencing eye color too, right? So for instance, blue eyes are eyes with very little melanin and lipochrome concentration, whereas green eyes have slightly more melanin and lipochrome. Combining the blue hue from Rayleigh scattering, from this phenomenon, and the yellowish tint coming from the lipochrome, a green iris is produced. And then you have a wide range of colors that can be produced in this manner, right? Hazel eyes, for instance, have more lipochrome than green eyes. And if you ever had the opportunity to see an eye in a slit lamp microscope or just a picture of the iris, and you can Google that, you will have noticed that sometimes people have different colors in the central part of the iris and in the peripheral part of the iris, right? The colors are different in these two sections. This happens because the distribution of melanin can vary in different parts of the iris. So hazel eyes may appear light brown near the pupil or the eye aperture, and green in the periphery of the iris. It's very cool, isn't it? Now that we've got the basics in the bag, let's answer a few questions that I frequently get. The first one is, can people be born with two eyes with different colors? And the answer is yes. Rarely, but yes. The name of this is heterochromia or heterochromia iridum, which essentially translates to the iris of your eyes having different colors. Usually it's not accompanied by any issue, although it can be a trait of several genetic disorders. If this heterochromia is noticed at birth, for example, we call this congenital, right? It can be either inherited from parents that have heterochromia themselves, or caused by mutations later down in more advanced embryogenesis stages, right? And we name these somatic mutations. So you may have a somatic mutation on a gene after several cellular divisions, for example, or in a later stage of the embryo formation, where the two eyes are already formed and separated. This could cause different colored eyes. A second question that I get very often is, can eye color change with time? And this is another yes. You can ask any mother, right? And she'll tell you, she'll swear to you that the color of her baby's eyes changed with time. And it most commonly darkens with time, right? And that's because as the baby is developing, right, more melanin gets produced. So the eyes tend to darken with time. Then eye color can also change with aging, right? And the scenario is usually the opposite. In this case, eye color changes with time due to a reduced concentration of these pigment-containing cells, right? We call these cells melanocytes. And these cells are the cells that melanin is in, which remember is a dark brown pigment. So in older individuals, the eyes tend to get lighter. So you may have noticed that the hazel eyes or green eyes of your grandmother with time have become particularly lighter, right? That happens. It's not a myth. Now, the third and last question that I get very often is, can your eye color change during the day? That's an interesting one, isn't it? That's a great question. The explanation goes back to Rayleigh scattering. Changes in light scattering can also change our perception of the color of an eye. They don't really change color in the sense of the word, right? They just reflect a different color. Remember that when you think about blue eyes, they are not actually blue. It's a structural color. So when you look at it like that, things such as the shirt you're wearing or the clothes that you're wearing, the lighting that it's facing you directly, or your mood, the weather, these can now make your eyes look differently because they will reflect light and the color differently. This is particularly noticeable in green eyes, for instance, when one day a green eye may look green and in another it may look more yellowish or more hazel, right? That's the nature of eye color. So I think I covered all that I wanted to cover. It's going to be a shorter episode, finally, right? Let me try to wrap this all up. There's a lot involved in eye color, and it's actually a quite complex trait. Although we have two pigments in the iris, one which is brown, the melanin, and another which is yellowish, the lipochrome, combinations of these two pigments with the influence of light scattering generate different colors. So be sure to let your green or blue-eyed friend know that they don't really have colored eyes. What they have is a combination of pigments and light scattering. Thank you so much for listening to me today. I hope you found this episode useful and that you can extract something from it. If it adds anything to you, no matter how small it is, I'm happy already. It's happy days. If you like our work, please consider giving the podcast a rating in whichever platform you are listening to this episode on. You can find us on @EyesOnResearch on your favorite social media accounts. You will also find a link in the description of this episode to our support website, which is what we are using to post our weekly newsletter. So go check it out. A huge thank you to my supporters. Thank you thank you all very much. Have a wonderful rest of the week, and I'll see you in the next episode. And as ever, my friends, keep your eyes on research. Bye bye.